Hi, I'm Chris, and today I'm here with Kayla, and I'm going to give you a brief overview of our senior project, which was the portable calorimeter for fire experiments. First, I'd like to introduce you to the team. Um, I was in charge of hardware and management. Kayla was in charge of manufacturing and budget. Joel was our testing and safety lead, and Kira was our software and design lead. The sponsor of our project is Dr. Richard Emberley. He's an assistant professor in mechanical engineering at Cal Poly, and he's also a faculty member of the Fire Protection Engineering program, which he has commissioned us to build the device for. The problem statement for our senior project was that Dr. Emberley wanted a portable oxygen consumption calorimeter, as current oxygen consumption calorimeters are too large to take into the field. On the right, you can see a picture of the cone calorimeter that uses oxygen consumption. This is currently in the combustion lab here at Cal Poly. Picture is only about a third of the device, and it is quite large, and you cannot move it around or transport it very easily. So our project goals were to reduce the weight and size of a device. We wanted to focus on creating a cheaper and more economical version, and we also wanted to maintain accuracy while measuring data. So the CAD model for our calorimeter consists of two major parts. We have our electrical system and our mounting plate. The electrical system contains our power supply, our pump, O2 and CO2 sensor, and in it also contains the smoke extraction system. And on the bottom, which it is attached to, is the mounting plate, which contains rubber feet, thumb screws, and handles, which attach it to a briefcase that it is mounted in for ease of transportation.
Here on the left, you can see a picture of the combustion lab with the existing fume hood and connected exhaust duct. We intend to modify the exhaust duct by adding inlet and outlet ports, as seen on the right, which our sampling lines from our device can connect to. Here we have our final build. On the left, you can see how the mounting plate fits into the briefcase, again with those thumb screws, keeping it secure. On the right, you can see how the mounting plate comes out of the briefcase and connects up to our laptop to display the collected data. So here's our graphical user interface we created using MATLAB. It shows the heat release rate as a function of time, and the graph updates in real time. We also have a data table at the top, which shows the collected data. And it's easily controlled using the run and stop buttons. So we've met our project goals. The calorimeter is quite portable, as it only weighs about 12 pounds and is easily transported once inside its briefcase. The device can measure its relevant gas concentrations and calculate the heat release rate, which is the value of interest. And the total cost of the device came out to around $1,300, which is much cheaper compared to other similar devices, as Chris mentioned earlier. If you'd like more information about our project, we encourage you to check out our other video, which goes into much more depth on the engineering side, as well as looking at our digital poster.